Okay, let's unpack this. Today, we're doing a deep dive into something pretty significant in robotics. It's Google DeepMind's Gemini Robotics On-Device. Basically, a powerful AI that runs entirely on the robot itself. Now, for years, as you know, even really advanced robot AIs have been, well, tethered. They've needed constant internet cloud processing, for instructions, decisions, and that dependence, it's always been a huge bottleneck, right? Especially in places with bad Wi-Fi or maybe high security zones.
Exactly. And that's why this new on-device model is such a game changer. It basically cuts the cord. It untethers these robots from needing those external networks. That gives them a level of genuine independence we haven't really seen before on this scale.
So no Wi-Fi needed to function.
For its core operations, nope. It means they can be reliably smart pretty much anywhere. It really empowers them to act autonomously out in the real messy world.
Okay, so it's cutting the cord. What is Gemini Robotics On-Device? Like, under the hood?
Good question. It's essentially a lightweight, very optimized version of the big Gemini Robotics AI from Google DeepMind. And its key feature, like you said, is running entirely on the robot. No internet, no cloud needed for its main tasks. It manages to pack some really impressive skills. They call them vision language action, or VLA skills,
Right.
into this compact onboard package.
That sounds like some serious engineering, fitting all that power locally. So, okay, it's self-contained, but what can it do? What are the core capabilities that really stand out?
Well, its abilities are pretty robust.
Yeah.
It can understand spoken commands, but also visual information from its surroundings. What's really striking, I think, is how it can handle objects it's never encountered before.
Never seen before.
That's right. It shows really strong generalization. It can adapt.
And the learning speed, that really caught my eye in the research. It adapts to new tasks with, sometimes just 50 to 100 examples?
Yeah, remarkably few demonstrations needed.
And I saw something about using the MuJoCo physics simulator. How does that fit in?
Ah, yes. So that rapid learning is helped by efficient training methods. Sometimes, it uses tools like MuJoCo. It's a physics simulator. So the AI can practice and hone new skills in a virtual world first. It's faster, doesn't always need a physical robot for every single test run.
Makes sense.
So this flexibility means it operates offline. It makes decisions right there in real time. And because it's all self-contained, it's great for secure environments too.
Okay, so this isn't just lab stuff, right? Where is it actually being used?
Right, not just theory. It was first developed and really put through its paces on Google's own Aloha robot. But it's moving quickly. It's already been adapted and is now running on, for instance, Eptronics' Apollo humanoid robot.
The Apollo. Okay.
And also on Franka FR3 dual-arm robots. So different platforms. And this is where it gets, really exciting for the field. This step is crucial for getting genuinely autonomous robots. Machines that can work on their own safely, flexibly, even when things get complicated or unpredictable. Think about it. Removing that connectivity need opens up deployment in remote places, maybe disaster zones or sensitive facilities where cloud reliance just wouldn't fly.
Yeah, places you couldn't send a robot before because of the network issue.
Exactly.
So it feels like a really significant step. But what about hybrid models? Combining cloud and on-device. How does this pure on-device stack up?
That's a great point. Look, a hybrid approach might offer, even more raw computing power for certain very complex tasks. But the performance of this on-device version, it's impressively close. And critically, it's more than good enough for a huge range of practical real-world jobs.
So it hits a sweet spot of capability and independence.
Precisely. It's powerful and self-contained, and that makes it incredibly impactful right now. So if we connect this to the bigger picture, Gemini Robotics On-Device really marks a fundamental shift. We're empowering robots to be truly self-sufficient, truly intelligent in their own right without needing that external tether. Which leads to a really interesting thought for you, the listener, to chew on. What new possibilities, but also maybe what new challenges arise when this kind of advanced AI lives entirely inside the machine, when it can learn and adapt on the fly anywhere? What could that mean for automation, for exploration, maybe even for the future of work itself?
Those are definitely some big questions to think about, a fascinating glimpse into where robotics is heading. Thanks for joining us on this deep dive. Keep exploring that future of tech. We'll talk soon.